Hello everyone, I'm Lavanya Vaishnavi. So today let us have a discussion on the programs which we conduct in Embedded Controller Lab. So today I'm going to take the topic displaying hexadecimal number on 7 segment display. So before going to the main code, let us understand what is 7 segment display and how the data is encoded on it. So 7 segment display. Why it is called 7 segment display? Because to represent any of the character, we make use of 7 segments here. So which are these segments? LED segments. Which are they? They are A, B, C, D, E, F and G. So you have one more segment which is H, which is used to represent the decimal point. So in this 7 segment display, like whatever the kit we are using in our laboratory to turn on any of the LED here. So that is to display any character. Say if you want to represent 1, you need to turn on B and C, right? So if you want to turn on these two LEDs, then you have to give the input as 0. So whatever the kit we are using, according to that I am telling. Now, if you want to make it glow, you need to give 0. If you want to turn them off, this is off, right? You need to give 1. Okay. So, this is the logic you have to understand. Now, to represent 1, how do you write it in 7 segment display? You need to turn on B and C. Rest all should be turned off, right? Like A, F, G, E, D, H, all should be off. That is 1. B and C alone should be 0. Similarly, if you want to represent 2, A, B, G, E, D should be turned on. F and F, C, H should be turned off. Similarly with 3. So whichever you want to turn on, you will give 0. Whichever want you turn off, you will make it as 1. Okay. So using this logic, I am going to write the encoding table here. So this is the encoding table where these are the hexa numbers what you are writing. The first column is the hexa numbers which is 0 to 9, A to F. Okay, 0 to F in total. These are the hexadecimal numbers and which is the equivalent code written here in the hexa value. Okay, now suppose you want to represent 1. If I want to represent 1, I told you before, like you need to turn on only B and C. What about the other LEDs? It should be turned off. The same thing I have done here. B and C are turned on, including H up to A. All other LEDs are turned off. Okay, so you are giving 1 here. To turn off, you are giving the value logic high. Okay, now look at this number. It is 11111001, right? It is 1111. What is 1111? It is equal to F. What is 1001? It is equal to 9. The same thing you are writing here. It is hexadecimal F9. Hexadecimal representation of F9. Okay, same thing, using the same method I'm going to write all the equivalent values. Okay, so if I want to write the value of 2, so if I want to write the value of 2, then F, C, H are 1. Rest all it should be 0. The same thing. Look at this. F, C, H are 1. Rest all are zeros. So what is this value? 1010. What is 1010? It is A. Okay. What is 0100? It is equal to 4. So like this you are going to encode each and every value. So this is what you get it as. So this is the hexadecimal equivalent 8-bit number for the hexadecimal values. Okay. Now in the next slide we will understand the operation, how does it occurs. Now you are writing a code on LPC1768. This LPC1768 takes the data and send the data to a shift register. We are taking the data and putting it on a shift register. This shift register is a serial in, serial out, serial in, parallel out shift register. So from pin 2.1 you send a serial data, one after the other, one after the other. So this one after the other data will be sent to the 7 segments using parallel data lines, Now look at it from 15. So it starts from 15, 1, 2, 3, 4, 5, 6, 7. So these parallel lines will send the data to A to H. Okay, and you have two clocks here. So why are these clocks used? Shift clock and latch clock. Shift clock is used to change the LED segment. Suppose you are operating at this segment, you have to operate the next segment. So to change this segments, you are going to use the shift clock. And why do you use this latch clock? We use this latch clock because you are having 1, 2, 3, 4, 5, 6 different LEDs. To change the clocks from first to second, second to third, 3 to fourth, fourth to 5 segment, like this, to change the 7 segments. So or to change the display segments, you are using this latch clock. Okay, so this is the utilization. First is shift clock to change the LEDs within the segment. To change the segment itself, we are making use of latch clock. Serial data is to send the 8-bit data what you have taken. Now I'll take one example data. So let me take the example data of A. So what is it equal to? A is equal to 88. I'll remember this. It is equal to 88 H. Okay. So I'll take the same data every time. Okay. So now serial data, if I want to send 1000, which is equal to A. If I want to display capital A, I need to send 1000. First I'll send this one. Next I'll send this 0. Next this one. Next this 0. Next this one. Next 0. Next 0. Next 0. Like this I'm going to send in a reverse way. First I'll be sending MSB, LSB, 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 then next. Like this it goes on. Okay, first I'll be sending this data. Okay, so these datas are they are given parallelly to this one. And shift clock, why use this shift clock? Once you send this first data to shift the next data, you use this shift clock. Why you use this latch clock? Once you have displayed A here, I want to display next A here. So to change the segment, I'll be using this latch clock. Okay, so understood about this? Hope it's a S. Okay, coming to the next one, 7 segment. So I told you, right, in the previous diagram you could see there were 6 hexadecimal displays. These are those displays, segment displays. These are the segment displays. This is 0, 1 and 2, 3, 4, 5. So there are 6 displays. So this is the first one. Once you display the value here, to shift it you may use latch clock. Once you display here, latch clock, then here. So once you give a latch clock here, it will display here. Once you give a latch clock, that is once you send a pulse in a latch clock, it will display here. Once you send a pulse in a latch clock, it will display here. So again, after one more pulse, it will come back and display to the 0th 7 segment again. So this process continues. Now, coming to the coding part. In coding part, you have included #include LPC17XXH. What is this 17XXH? I am writing the code for LPC1768 whose registers are stored in the header file 17xxh. So I include this 17xxh. In this I am calling two functions. These are the definitions of the function. One is display function and the other one is delay function. Why do you use this display function? Display function is used to display the characters on the 7 segment. Delay is used to generate delay between each display. So the clock frequency or operating frequency of your LPC1768 is very high, and we are not so sensible to read in such a speed. Therefore our eyes are not so sensitive. Therefore we usually induce this delay to make us analyze. Okay, so this delay is to generate delay between each displays. And display unsigned character value. Unsigned character is a data type. Okay, character is a data type. In that specifically I am taking unsigned character, which is a data type. So this unsigned character is a data type and value is the variable. Okay, so here also in delay, unsigned int is a data type. D is the delay value what you require. Now the first one is unsigned character. I have to define this. I am defining a global variable here where unsigned character is an array. So it has a, what is it is having? It is an array whose name is data. It is having 16 characters in it. It is having 16 elements in it. Okay, it is having 16 elements in it. Which are these elements? These are it is C0, F9, A4, B0, like this up to 80. This represents number 0 and this represent alphabet F. So these are the hexadecimal numbers that you want to display. Okay, the next slide. In the next slide, we discuss about main code. In the main code, you can see that you have unsigned character ij. What is this unsigned character ij? These are the two loop control variables you are using here. Okay, so I want two variables to control the loop. Therefore I label them as I and j. Next is I am using general purpose input output port 2, GPIO port 2. So in that I have to define the direction. So how many pins I need to monitor this? I need only 3 pins, right? I need only 3 pins. One is to monitor shift clock, one is to send the data, the other one to send the latch clock, right? I need only 3 pins. Which are these 3 pins? 2.0, 2.1 and 2.2. 2.0, 2.1 and 2.2. So pin 2.2, 0, 2.1, 2.2. If I want to make them as output port, I need to give 1. So it is 111. What is 111 or what is 0111? It is equal to 7, right? So the same thing I am writing here. So look at this. So FIO, fast input output, direction, you are making it to 7. So look at the next slide. Here I am doing the same thing. So FIO to dir, I am defining the direction here. If you give 0, it takes as an input. If you give 1, it will be made as an output. Now I am taking this GPIO port 2. It has 32 pins from 31 to 0. The last 3 pins you are making it to 111, right? So this 111 is nothing but the output pins. The same thing I am writing here. Pin 2.0 is to propagate the clock pulse to move from LED to LED, that is shift clock, for shift clock. And 2.1 is to send the serial data, 2.2 is to propagate from segment to segment, which is called as latch clock. Okay, now look at the next instruction. Now in the next instruction I'm taking while of 1. I'm taking while of 1. What is this while of 1? It says that you are defining a loop which is infinite loop. That is, you want the loop to be executed continuously. You don't want the loop to turn off. Okay, or you don't want the loop to exit out. Therefore you are defining an infinite loop here, while 1. In that you are defining a for loop. You are defining a for loop. In this for loop you are taking 16 repetitions or 16 iterations. Why 16 iterations? Because you are having 0 to f 16 numbers to display. 16 numbers to display, therefore you are taking 16 iteration. Okay, so how many times you have to display the 0? You have to display the 0 on 6 different LEDs, 6 different segments, right? See how many segments you are having. 0 to 0 to 5, right? 0 to 5. So 6 times you have to display the 0. If you are taking any alphabet, I told you, let me take A. A is represented as 8 8. So you have to represent this A 8 times. Here you have to represent 1 time. See, here you have to represent as A. Here also you have to display A. Here also you have to display A. Here also you have to display A. Here you will be displaying A. Here you will be displaying A. So how many times you displayed? You displayed 6 times, right? So the value of J here you take it as 6. The value of A you are taking it as 6. For I equal to 0, I less than 16 indicates you are having 6 hexadecimal 16 hexadecimal numbers. For j equal to 0, j less than 6 is nothing but to turn on 6 LED characters. Okay, next, display data. Now before coming to this, let me explain for loop and later I'll go for the display and delay. Now I'll take the value of I equal to 0. I'll take the value I equal to 0. It enters the second for loop. Now it will take j equal to 0, j less than 6, j plus plus, and it will start display data of I. Display data of I. So display data of I means, so what happens here? What is data of I? Data of I will be having the value of the characters what you want to display. So I told you before, so there you have 0 1 2 3 written in coded language. That coded data will be given to here, will be given to here. So and it will be sent to display function. Once it is displayed, you will take a delay of 50 in the, you will generate a delay of 50 here, and then it will go back. It will go back. Increment the value of I becomes 1. Again it will come back. It will display the next value. Suppose if it is displaying 0, next it will display 1. It comes to the second for loop, display 1, it will start displaying the value 1 in the first segment. Next it will increment, the value of j will increment, so it will go for the next segment and display. Again it will increment, j will be incremented, again it will go for the next. So like that it will keep on incrementing until the value of j is equal to 6. Once it becomes 6, so this condition will be false and hence it will come out of the loop. It comes out of the loop and takes a delay of 50 and then it will go back to the for loop. So this process continues. This process continues until your value of I is equal to 16. When the value of I equal to 16, when the value of I is equal to 16, it will stop iterating and come out of the for loop. It will comes out of the for loop. So like this it will comes out of the for loop and go and check for the condition in the while loop. Because here you don't have any condition, while loop is always true when you write any number in it. Therefore, while 1 will continuously execute, and hence you will be having a continuous display on the LED displays. Okay, so next is display function. Next is display function. Coming to the display function, so I told you before, you are having unsigned character as data type. The value or the variable is the value. Value will be the variable. Now I am taking an unsigned character m. Either you can take it as a character or you can also define it as an integer. So I need one more variable for the iteration. Therefore I am taking m here. The value of m, what is the value of m? M should vary from 0 to 7. M should vary from 0 to 7. Why from 0 to 7? Because to represent any of the value or all these hexadecimal display, that is 7 segment display, has the value from A to H, right? So A to H it is 8 bit. A to H is 8 bit. Therefore, you take the value 0 to 7. Okay, so first I'll take any one of the value. Now I'll go back to the table and I'll choose any one of the value. Okay, so I'll take any random value. Shall I take this? I'll take the value of D, so which is equal to A1. A1. How do you write A? 1 0 1 0 1 0 0 0 1. So now I'm taking the value A1. Okay, so I'll come back to the slide. I'll take the example, or I have taken that. I've selected the value A1, right, which is 1 0 1 0 0 0 0 1. So this represents A and this is your 1. I have taken the value A1. So this value is A1 now. The value of this variable value is A1. Okay, I'm taking this value. Now this A1 has 8 bits in it, right? It is having 8 bit. In this, what I'm going to do is I'm adding this value with 1 0 0 0 0 0 0 0, which is nothing but 80, which is nothing but 80. When I add it, so it means that you are discarding all the lower bits. See, once I add with 0, it becomes 0. Everything is 0 except the first number, right? Except the first number, because it is 1. Okay, so now this is 1 0 0 0 0 0 0 0. It means that this is a complete number, or this is a number where you are extracting only the MSB. You are extracting only the MSB. Now you have extracted the MSB and you have to check this MSB. What is the value of the MSB? If the value of MSB, see, if value ampersand 80 is equal to 1. So if this, what does this means? If it is equal to 1, execute this. If this is not equal to 1, then execute this. Understood? So if this value equal to 1, because it is equal to 1, you are setting the value. You are setting the value. If it is not equal to 1, then it will clear the value. Then it will clear the value. Now let me understand this part. So look at the next slide. If the value ampersand 80. So here you have taken different example, which is A4 I am taking. So now if it is equal to 1, you are setting the second bit. What is the second bit? Second bit is nothing but pin 2.1. It is pin 2.1. So check the MSB for 1. If it is equal to 1, make the output as 2.1, which makes turns off the LED, which turns off the LED. Otherwise, if the value is not equal to 1, if it is 0, then it clears the output. It clears the output. Okay, so once this part is executed, so let me imagine that this is your LED segment display. This is your segment display. In that, I'm displaying the 8th bit, which is H. So here this is turned off. It is turned off. I'll take the color because you are turning off. So it is off now. Black is off. Okay. Next, what is the next step I have to do? Once this is off, I have to move my control to G, right? I have to move the control to G. So I assume that I have moved it. How I am going to move that I'll just tell you in the next slide. So once I have moved there, now again I'll shift this bit, that is 7th bit, to the next position, to the left position. So it becomes 0 1 0 0 0. Sorry, this is 1 and 0 0 0. Okay, so now this 0 is here. Now again I'll check this condition, it is 0. Okay, so if it is 0, you have to turn on the LED, right? You have to turn on the LED. Therefore this will turn on, this will turn on. Like that, each bit you are going to shift it, each bit you are going to shift it. How many times you will shift it? You will shift it 8 times. What is this? Which parameter defines this 8? M defines the 8. M is defining the 8. So look at the previous slide. The same thing is happening here. So look at this. When it is equal to 1, when the value ampersand, that is when the MSB is equal to 1, then you are setting it. When the MSB is equal to 0, you are clearing it. Okay, once you clear it, you will give a pulse. You will give a pulse to GPIO 2.0. Once you give the pulse, the control will move towards the next bit, right? So if it is in H, it will move to G. After glowing or turning on or turning off the LED G, it will go to F. Once it operates on F, it will go to the E. Next it will go to D. Next it will go to C, B, and finally A. Like this it will turn on or turn off each LED. So according to the data you give, it will turn on or turn off the LEDs. Okay. And so to move the control from this to this is the instruction you are giving. Once it move, you have to shift the values also, right? Here look at this, look at the next one. I told you this should be shifted to the previous one, right? This should be shifted to the left side. To shift it, you are making this, you are giving this instruction, value less than equal to 1. That is, you are shifting the value equal to value towards left shift by 1 position, left shift by 1 position. So once you left shift until the value of M is equal to 8, this complete loop get executed. Once the value of M reaches the value of 8, this condition becomes false and it comes out of the loop. It means that once the value of M is equal to 8, it has turned on all the LEDs. It has turned on all the LEDs. Once all the LEDs are turned on, it has to move to the next LED. It has to move to the next LED. So it will move to the next LED and it will turn on now. So to move, you are giving this part of the instruction. Now coming to the shift clocks. So I told you that shift clock is given to pin number 2.0, pin number 2.0. So this is pin number 2.0, right? See, it is 0, so it is pin 2.0. Okay, so to pin number 2.0, you will give 1 first. That is, you are setting it, right? After setting it, once you get a set, you will get a high pulse. Then you will clear it, making it low pulse. So you will get a shift clock here. So you will get a shift clock. What the shift clock will do, it will glow or it will shift the control from LED to LED. That is, if you have 7 segments here, right? If you have 7 segments, so first the control will be towards H, then the control is moved towards G, then move towards F, E, like that. So the movement of this is controlled by shift clock. This movement is controlled by shift clock. Next is latch clock. So the latch clock is given or controlled with pin number 2.2. So this is 2.2. So pin number 2.2 initially is given with 1 and next you are going to clear it. Sorry, make this as 0. Okay. So next you are going to clear it. Once you clear it, it becomes 0. It becomes 0. So you know that there are 6 different LEDs there, right? 6 LEDs you are having. So now each LED should be glown. Each LED should be glown. So from LED to LED, if you want to shift the control, from LED to LED, if you want to shift the control, you will make use of latch clock. So you will give a set and clear to pin number 2.2 as a clock pulse. So like that, you are changing the LEDs and changing the segments to display. And the last one is delay function. So how does a delay function works? You know already. You have studied it in many programming languages also. So here void delay unsigned integer d. So you can also change the value of d depending on your requirement. There I have given in this code I have taken 50. You can also vary it. Now I am taking two integer values, integer I and j, for looping purpose. I'll take the value of j equal to 0, vary up to 9999 times. Okay, and once it is varied, then again I'll go back and increment the value of I until it reaches the value of d. Here d I have taken it as 50. Therefore, for loop with I iterates 49 times and j loop with then for loop with j iterates 10,000 times. Totally, there will be an iteration of 10,000 into 50 times. Okay, so many iterations will create a small time delay, and this is how the delay function works. Now, to execute this, you have to make use of FRC1 for the given for the laboratory accessories what you have in our lab. And finally, so how does the output looks, that we are going to, that I'll upload it in the next video. Okay, thank you for watching this video. If you have any doubts, you can write me back or you can contact me. So like the video, share with your friends, and don't forget to subscribe my channel. Thank you.